Linux In-Laws, a podcast on free Libra open source software. Broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, a season 2, episode 68. Martin, 68, that is just one short of 69, no?
Well, yes, but apart from that, it's obviously a good number.
Wouldn't be 69 your favorite number? No, I wonder.
No, 68 is much better.
Why? I mean, you can't turn it upside down.
The year I was born, that's fine.
As in, you are.
It's a brilliant vintage.
You were born in 1868. I'm impressed.
Who knows?
What's the secret order of Julia or something?
Yeah. Well, that's why it's a secret, obviously. Anyway.
Okay.
How are you?
No, anyway? You are 100 and plus years old.
Well, maybe more.
Excellent.
So how are you?
We should speak to our beloved Countess about this.
Oh, yes. Well, she has a lot of handy tips on this.
Absolutely. I am okay, I suppose.
Good.
Excellent.
Glad to hear it.
And I'm even better giving our subject for tonight.
Oh.
Which happens to be exactly what...
Oh, something about RPC and stuff like that.
The metal control protocol, right?
No, we'll come to that at the end. I thought we would start at the start today rather than at the end. We can start at the end for a change.
No, well, okay, a little bit of background for the audience so they don't get lost right from the start. The MCP, of course, is standing for Model Context Protocol, something that is used by the hipsters to talk to LLMs and other fancy AI gadgets. But when we kind of discussed this episode, I had the idea of doing an episode about how processes talk to each other.
Okay.
As an
the whole thing is about processes communicating.
So
which
let's
protocol is kind of irrelevant in a way. Yeah.
Exactly.
We can talk about some of them. Yes.
Anyway. So let's start in the 60s.
Oh, can we start in the 90s?
No, we cannot.
Oh, damn. Okay, go on then. You tell us about the 60s.
The second most important event that took place in the 60s, apart from Martin being born, was the invention of large computers called mainframes.
Yes.
And these mainframes had a particular feature. They were able to...
They were big.
Yes. If size matters, Martin, you have...
Yes.
Yes.
Anyway, carry on.
They cost a lot of money, too.
Indeed.
They still do.
They still do, yes.
And at the end of the 60s, they were able to run multiple processes at the same time.
Aha.
And these processes had to talk to each other.
Well, you say that, but they didn't necessarily have to.
Well, it depends.
Doing, right?
Exactly. Indeed, very much so. So in the beginning, they used paper tape.
No, but that's irrelevant of whether they need to talk to each other.
And slightly fast-forwarding things. No,
okay.
I mean, jokes aside. I mean, let's start really in the beginning. What is a process? In operating systems / layman's terms.
Good question. What is a process?
It's something that does something, right?
Yeah. Well, yeah. Okay. Yeah. I mean, obviously, process is also not related to computers, but yes. Yes, it is a thing that has inputs and outputs and does a thing. That's the kind of high level.
Yes.
Yeah. Okay.
In operating system context, it does have an address space. It does have a CPU slot every now and then.
True.
It does have I/O features to some extent.
Yeah.
But the thing is, basically, it can't really escape the address space because that's normally protected by the operating system. You will probably recall the beautiful zero-pointer problems, and among other things, these things cause actually segmentation faults, for example, in Unix operating systems like Linux, BSDs, and all the rest of them. So they're confined to their address space, but if at the same time they have to talk to other processes running on the same machine or someplace else. How do we go about this?
How do we go about what? Sorry?
About process talking to each other.
Well, you need to define some standard communication models and interfaces, right?
It's called an inter-process communication. And with that, we would like to thank you for listening. No, we're still talking kind of the late 60s. And one thing you could do actually is actually files, right? A file system where one process
Oh, I see.
writes
You
the
can use
file.
files to communicate. Yes, sure.
Exactly.
Yeah.
Another one
you can use
reads
files.
them.
You can use sockets,
Yes,
whatever you like, right?
And already Martin is onto something here. What are sockets, Martin?
It's what are they? Let's say a non-physical port on your OS. Well, actually, a socket is really just an object on your file system that, process can listen on and write to.
Yes, in Unix term, a file descriptor, exactly.
Mm.
Now, sockets have two very interesting properties. Either they can be local or they can be remote.
Mm.
The local sockets would be known as Unix domain sockets, UDSs. And the other ones would have a protocol stack attached to them, more likely to be either UDP or TCP.
Mm.
But first of all, what's what I'm looking for? Why is intercomputer communication important? Just rather than kind of...
That's, I mean, this is kind of, again, goes back to the... through the to history, where people decided that having great big programs that did everything on its own was not just a great idea for maintenance and stuff like that, and understanding. So they started breaking things up, and then the things that they broke up obviously had to talk to each other. So
absolutely, and at some stage, because these mainframes were so bloody expensive, they decided to go for cheaper hardware and let these cheaper hardware talk to each other via a so-called computer network. You're talking about the...
Well, yeah, but it doesn't have to be we talked about sockets, which can also be on a single machine. But so it doesn't have to be computer to computer, right? It can also be different...
Process to process, exactly, yes. And at some stage, basically, the internet was invented. I'm just setting the scene here for the later stage of the discussion. And then these computers, as it so happens, could be on the other side of the planet, in terms of one computer being located, say, in San Francisco, and another one being located in Moscow.
As long as there was a network, yes, indeed.
As long as there was a network, these two computers, of course, being located in the respective secret service entity of said country, could talk to each other, exactly. If not prohibited. Let's put it this way. No, jokes aside, with the need of computers being clustered together, and cluster is actually the key word here, never mind wide area networks.
Anyway, keep going. I'll come back in a minute.
Exactly. The necessity arose for computers and for processors running on these computers to interact with each other more and more. Clusters, of course, being the notion of collating computers in one kind of closely knit network for the benefit of increased resilience, high availability, and all the rest of it, and wide area networks for disaster recovery and some other stuff. As in, your data center fails, so do the computers in that data center. So you have to switch over to a different data center, but you do that so we're using network, so that any client applications who previously were talking to the original data center, which has just gone down, can now talk to the second data center, acting as a backup. And with that, we have introduced already a very important notion, the notion of client-server networks in terms of architectures.
Yeah, I just wanted to add a little bit to that, because, I mean, it's not just about clustering in HA, right? It's also about distributing processes for whatever you try to do, right? It doesn't have to be a copy of the same processes for resiliency. It can just be, we need more computing power, we're going to run some of these processes somewhere else, right?
But I thought we left Kubernetes and some other newfangled stuff until the very end.
No, it's nothing to do with Kubernetes. I mean, this is pre-Kubernetes when people started doing this.
Absolutely. And some people took it to the extreme, because when you take a very close look of how, for example, sockets are implemented in Linux and other operating systems, essentially you're talking about a kernel buffer that is shared between two processes. And some people rather, took that notion of shared memory to an extreme and came up with the idea of, okay, we can actually share the address space across a network, coming to the notion of NUMA, non-unified memory access, in terms of it doesn't matter where a couple of pages of memory reside, whether in your on the same computing plane,
NUMA
in
is
the same rack.
CPU to CPU, though, isn't it?
Yes, but you see, the operating system supported by the hardware takes care of the details. I mean, if you fault on a page that is not present on your main board or in your rack, on your network, basically, something will identify that page and will make sure that, worst case, that memory page is paged in from a machine on the other side of the planet.
Well, from disk, surely, first. But...
It depends on the page. What I'm saying here is actually that the kind of the abstraction is, if you access something that is not present, either you get a segmentation fault as in a signal that you can't do this because you're not allowed to and all the rest of it, or some other entity will take care of getting that page to you in a more or less transparent fashion, if you're talking about shared memory. But IPC goes way further, of course. Martin already mentioned sockets, but there's more. There's signals, I already mentioned that. The original Unix also supported message queues, confined to actually a local machine, because message queues in the original Unix design couldn't cross machine boundaries, and the fancy stuff came later. But all these mechanisms had one important property. They were just conduits. In terms of
communication.
Exactly, you could just pump bytes through that conduit, and that's as far as it goes. Now, that would require that sending processes and receiving processes have a very good idea of how this data is structured, speak the same ISA as in possibly instruction set architecture, and know how to deal with the data being pumped through. But taking one step back, if you're talking about programming languages, not all programming languages are created evil. Exactly. Not evil.
Well, there's probably isn't there an evil programming language? I'm sure there's.
Many.
Isn't it? Yes. Anyway, carry on.
So different programming languages have a different idea of, for example, of how data is structured. You're talking about structs, unions, composite data types in general, all the rest of it.
Sure.
And then you have the beautiful set of properties that certain instruction set architecture have different ideas of, for example, how these composite data types, as defined by a programming language, are structured in terms of big endian, little endian for the hipsters among us. That has to do with byte ordering and how atomic values are stored, essentially, floating points, integers, and all the rest of it. So the idea is basically to take a step back and to come up with a mechanism that abstracts away these machine dependencies. And now we have arrived at the beautiful notion of remote procedure calls. What is an RPC, Martin?
Well, it is it's an abstraction, right? As you mentioned.
Absolutely.
So, as the name says, you can call a function on a different process or a different machine, even.
Yes.
And it takes care of the networking, the serialization stuff, and all kind of things, right? So it's kind of a abstraction layer. There's a remote procedure call, and it does a bunch of stuff for you to do make the physical stuff happen for you.
Exactly, and very important features actually, or two important features. A, the calling process in terms of the process that invokes that remote inverted commas procedure is under the impression it's talking to something that is very close by in terms of ideally in the similar address space. It's not aware of the fact that this that the target procedure may actually be on the other side of the planet, running on a totally different machine architecture and being implemented in a totally different programming language with a the really different idea of how data is structured and all the rest of it. Push comes to shove, in an ideal case, what the caller may perceive as actually a small delay once it's invoking a remote procedure. In the worst case, it may be under the impression that part of its address space, in terms of part of its software, is gone because the receiving end has just decided to die. Too bad. This is the reason why more sophisticated RPC protocols actually implement features such as resilience, high availability, and all the rest of it to prevent exactly that. But the bottom line is essentially a caller will not perceive, apart from a small delay, any difference between a local and a remote procedure call in the ideal world. Because the environment will take care of the rest in terms of it will marshal any arguments, and this is the key word here. It will marshal any arguments, put this into a machine-independent representation and also independent from the exact programming language being used, and then shovel this off to the remote machine in a remote network. There, the callee will take care of business in terms of executing the code associated with an RPC and transfer the result back, and where this is then unmarshaled and forwarded to the caller.
Okay.
Yes.
Yeah. So we probably need to talk a little bit about what that actually means, right?
Let's use one example of a very popular RPC package called gRPC.
Oh, what does the G stand for?
I wonder what that stands for. Could it have to do with our favorite search engine called Google?
It isn't our favorite search engine, though. It's not.
Yes.
Open source, so, yeah.
But gRPC was conceived by Google, and it uses a very interesting component called protobuf.
Well, protobuf is the actual, let's say, the data format or the.
That is exactly the underlying machine-independent data representation of data types, exactly. And this is powered by an IDL, an interface definition language. And an IDL is a very core component of any RPC mechanism, because that IDL actually takes care of how interfaces are defined, hence the name, or the acronym rather. And what gRPC is actually, it does, it's available, and links of course will be in the show notes, it's available for a huge number of programming languages. It takes the interface definition languages and, in collaboration with protobuf, generates the caller and the callee side of things in the programming language of your choice, and then makes sure that the caller can talk to the callee in a machine-independent, program language-independent, transparent fashion.
Yeah.
And that's RPC explained.
Yeah, well, RPC
or
is
is it?
the communication part, and protobuf is the actual data piece, right? Well, there's a bit more to it, right? I mean, do you know why it's what its original name was? Before it was renamed gRPC.
Alexander, Hugo?
No.
Fast?
It was called Stubby.
Stubby? Why, Martin? I wonder.
Oh, because
it was stubborn.
Some stubs.
I thought it was stubborn or something.
No. Yeah.
So, Martin, what is a stub in that case?
A stub is well, you're both on your client side, and you know what a stub is. It's like a.
Well, maybe the audience. Well, maybe the audience doesn't.
No, but you know what the word stub means, right?
Yes, like a cigarette stub.
Well, it's like a skeleton or something like that, right?
Exactly.
Yeah.
So the caller is under the impression it talks to a local procedure, but essentially it's talking to a stub, and vice versa on the callee side.
Yep. Yeah,
and
so that's why they call it stubby to start with.
Exactly, and of course they use, or gRPC uses, I think it's TCP bound. It uses one of the protocols, as described earlier, to ensure that it can talk about that it can talk across network boundaries and machine boundaries and all the rest of it. So, with RPCs out of the way, what other IPC mechanisms are there?
What other IPC mechanisms?
You're using this every single day if you're using a Linux machine, especially with a graphical desktop attached.
Oh, that sounds like a bad idea.
Yes, Martin. But you see, even
you don't want to do that.
Martin, even if you're using system control, which is the front end to something called system D, you're essentially using that communication mechanism.
Right.
And it's called a message bus, and it's called D-bus, as it so happens.
Oh, okay.
What's D-bus?
Yeah, okay, fair enough. It's isn't it like a digital bus or something?
No, it's called the desktop bus, Martin. Yes. Because
what kind of a name is that?
The hint is actually in the name, because in contrast to other IPC mechanisms,
desktop bus then.
Yes, it cannot leave a machine. It's only local.
Okay.
So it uses actually.
This is far less interesting than gRPC, really. Isn't it?
Yes, Martin, but it has a very important notion.
Nobody uses Linux desktops.
No, Martin, but if you use Linux.
Okay.
Sorry, let me be precise.
If you're using system D, yeah, that's fine. Then system C,
if you use a Linux system younger than about 20 years, chances are you're using DBus.
Okay, fair enough.
No, I mean, why is this kind of very similar to RPC? Because it's typed, and it's resting on interfaces, because essentially what you do is, and you can actually inspect this, there are a couple of front ends that allow you to drill into the bus itself. Details, of course, within the show notes. And why does this have to do with graphical user interfaces? Because it was originally invented by either KDE or GNOME that had to come up with a bus system that would allow components to talk to each other, as in applications and all the rest of it. So if an application basically would like to inquire about, say, the power management being present on a machine, it would go to the system bus, which is unique in the system because there's only one of them, and would talk to the ACPI daemon and would inquire about whether the machine is capable of hibernation and all the rest of it. You see this actually if you invoke any display manager of your choice, because more likely than not, that display manager is actually able to hibernate the machine, to shut it down, to restart, and all the rest of it. And that functionality would be implemented by the power system, represented by ACPI or some other stuff. And internally, they would use DBus to do exactly that.
Yeah, there's a whole bunch of fun things that use DBus, right?
Exactly. Yeah. Especially a so-called session manager that is invoked basically once you start your graphical desktop environment, because there are session DBus instances and there's only one system DBus instance. And that's the very kind of difference between the different DBuses. And internally, they have a couple of mechanisms at their disposal, but more often than not, they use either TCP-bound or Unix domain sockets internally, because they cannot really cross machine boundaries. So more often than not, they use UDSs, but
it's like, why would they need to use TCP then?
It depends on it's actually on the handshake, basically, that is implemented by something called libdbus when they set up a connection between an application and the bus. Some applications, for legacy reasons or whatever, prefer TCP-bound connections, but more often than not, they rely on UDSs, but you just prefer for performance reasons, because essentially you do not need the full network stack if you're just kind of communicating between applications running on the same machine, goes without saying. Fast forward, component models.
Oh, well, we finally at the 90s. No,
yes.
we'd already talked about gRPC, so that's
yeah, but
post-90s. Yeah.
What are component models, Martin?
Component models. Well, it is the what we talked about, taking a big thing and shoving it into components.
Exactly. And why is 80s and 90s, and not just Microsoft, because Microsoft came up with the COM idea, later also renamed to DCOM, but we're going to touch upon that in a minute. Why became that important? And COM is not the only component models. There are also Corba, XPCOM, and SOAP, and all the rest of them.
Fun.
Yes. Why were they invented in the first place?
Well, it's certainly because people needed smaller stuff that they could break up, right? So because
hence the rise of the rise of the machines, right? It's going to take place in 2050. It's called Skynet, and it's not pleasant.
Oh, I thought it was 2035. Anyway,
no, we're talking about the rage then, called OOPLs, object-oriented programming language. Exactly, Martin. We're talking
what
about
happened to them? I wonder.
No, Martin, they're still around.
Oh yeah,
but they really made a debut in the 80s and 90s.
Mm-hmm. Yep.
Hence the notion of object-oriented Visual Basic for applications, or whatever it was called. No, I think it later evolved into something called .NET, right? As a device by Microsoft.
Okay.
Yes.
Who knows? Oh, actually, what's his name? Our friend from the Grumpies. He probably knows, doesn't he? He's a bit of a Microsoft geek, I think.
There are two of them.
Are they both Microsoft geeks? Okay.
No, there's David and Thomas.
Yeah, I thought David was a Microsoft. Anyway,
are you sure?
I thought so. Anyway,
why?
Who knows? Who knows?
He works for an open core company.
Yes, but it doesn't always work. Anyway,
it doesn't really matter. No,
moving on. Yes.
Moving on. Exactly. So, what was the big thing in the 90s?
Well, the music was rubbish, as I said.
Yes. No, I'm talking about OOPLs now, as in distributed object-oriented programming languages.
Oh, is this the SOAP nonsense?
No, I'm talking about the Corba thing.
Corba, Corba predates SOAP, doesn't it? Yeah, you're right. Okay.
Yes, indeed.
Yes, equally.
The idea was to have a common object request broker architecture at your disposal.
Yeah.
And the idea was basically to take RPC to the next level. In terms of you have objects that talk to each other, independent of the programming language, independent of the exact implementation of the object model, all the rest of it.
Yeah.
And they would do this across machine boundaries. Fun fact. But
that's the same as XPCOM, though, isn't it, really?
Oh, absolutely.
Okay.
XPCOM is only local, and it was done by Mozilla. But Corba was done by something called Oh My God.
Oh, yeah.
As in the OMG. And funny enough, no, it doesn't stand for Oh My God in that case, but rather for the Object Management Group back in the late 80s, early 90s. Fun fact, I did my PhD in the very same university that had a very important offspring at the time called Iona Technologies. And Iona Technologies, we're talking about early 90s now, had the first, or one of the first, Corba implementations at the ready called Orbix at the time. Right. Exactly. They made a fortune. It was, I think, the highest valued IPO. No, Martin, bear with me.
Okay.
I'm not talking about today. I'm talking about the early 90s. There is a difference. You're talking about 30 years now plus. Okay. They had the highest ever IPO, I think, in NASDAQ's history. If memory serves correct. Details maybe in the show notes, kids. Okay. And some people really got rich, and I was just kind of sitting on the sidelines observing them.
Oh, that's a shame. Yeah, okay.
But no, jokes aside. No, I mean, they were pretty successful in that regard because Corba was all the rage then. And as I said, kind of early mid-90s, and it's still around in a couple of legacy applications. I think Boeing still uses Orbix, yes, if I'm completely mistaken, for some applications that are about 30 plus years old. But SOAP came later, yeah. So what is SOAP? Apart from this bar you have sitting on your sink doing nothing, apart from two times twice a day.
Service-orientated architecture, something.
Service-oriented architecture protocol, right? That's exactly it.
Is that okay? I just remember the first bit. Yeah.
Exactly. So Martin, what is SOAP?
Well, I tried to stay away from it in the 90s because it sounds like a load of nonsense.
And your parents did agree because of lack of personal hygiene. I'm impressed.
Yeah.
Apparently that has changed ever since because the last time I met you weren't that smelly.
Indeed.
So things apparently have changed, and Martin has grown to love SOAP, apparently, among other things.
Well, the physical one, yeah.
So what is SOAP? SOAP is essentially the idea of...
I remember now. Listen, there's something to do with XML as well.
Or JSON, yes. JSON came later, XML
JSON
was
came
first.
later,
Yes,
yeah.
exactly.
Yeah.
So the idea, and this is basically where SOAP came from, I'm simplifying things now, to have
XML.
Java, exactly,
yeah.
Java objects talking to each other. Exactly.
Exactly. I remember why I stayed away from it. Yeah. Anyway, carry on. Yeah.
Oh yeah, again, we're talking about
Java,
90s,
XML.
early 2000s, exactly.
Yeah.
The idea was to have Java objects distributed across the network, being able to talk to each other using a standardized language called XML. Needless to say, there's a vicious rumor in the marketplace that actually companies like IBM and some other kind of backers of that protocol were behind this, because of the beautiful idea of setting lots of memory plus lots of storage, because that's exactly what you need if you want to have a SOAP stack at your disposal. And the more the better, because it's XML, yes.
And
so
a lot of people to be able to decipher all this XML nonsense.
And of course, you need lots of CPU power if you want to parse and validate XML, as we all know. Yes. And with that,
good thing I stayed away from that. Yeah. Anyway, yes.
And fast forward another couple of years, we have now arrived in the hipster age.
Well, the ex-hipster age, but yeah, carry on.
Is it? Okay.
The previous hipster age. No, carry on. Yeah.
No, I'm always simply saying the current hipster age, because at some stage people came up with the idea of that monoliths are way too important. Sorry, Nick, it's not important, but rather that monoliths. Let me repeat that once again. That monoliths are way too expensive to maintain and develop. So they come up with this notion of microservices as a smaller code base that does
where they got that idea from.
Exactly.
Anyway.
That does one thing and one thing right. Talking databases, queuing systems, web servers, and you name it. So rather than kind of doing it all in one code base, the code base was split up and implemented separately. But of course, these components would have to talk to each other. But because they were hosted on networks that had firewalls in between them, that had other security mechanisms slotted in, they had, what's what I'm looking for, deep content inspection from a security perspective. They had to rely on standardized protocols and payload definitions like HTTP, HTML, and XML, and all the rest of them. And hence the notion of web services, for example, as in JSON-based payloads that would easily pass firewalls, would allow deep packet inspection, and all the rest of it. And hence REST was born, which is essentially the idea of taking RPC to the next level in terms of you're not kind of catering for individual programming language, but the programming languages basically are aware of the fact that they're talking to a remote entity. And
what is REST anyway?
It's standing for representational state transfer. The idea is basically...
Isn't it just JSON over HTTP or something?
Essentially, yes.
Okay. Right.
Yes.
Yeah. Okay.
I mean, this is basically, you see, Martin, this is one of the few exceptions that proves that rule that marketing is actually good for you. Because in that case, it's not.
No, I would agree.
No, jokes aside, essentially, it's a fancy term for putting a state of an application into a JSON-based HTTP packet, and that's sending that across the network, where hopefully somebody else will pick it up and do something with it, in layman's terms. So this is kind of a loosely coupled distributed application structure. Let's put it this way, where in contrast to RPCs and all the rest of them, the callee and the caller are aware of the fact that this is crossing address space, machine boundaries, never mind perhaps network boundaries, with all the fancy security mechanisms in place, like firewalls and all the rest of it, maybe even CDNs and content delivery networks. So the idea is actually, and this is basically why that plays along microservice so well, I reckon, that microservices are aware of the fact that they have to talk to other entities, but these other entities are elsewhere. Not necessarily in the same network, not necessarily in the same wide area network or whatever, maybe on the other side of the planet. In contrast to RPC, they're fully aware of the fact and also can deal with resilience and recovery aspects. More often than not, the supporting application libraries have that functionality baked into them. So if a target fails, something else hopefully will pick it up. Or the client side will initiate a retransfer or something like this. So this is the idea behind REST, and of course, with the advent of hipster programming languages like JavaScript, TypeScript, and all the rest of them, a suitable notation was required. So they arrived at something called JSON, which of course stands for JavaScript Object Notation. Exactly.
Yes, I remember that one. But we should also talk about the whole speed thing of these things, right? So because XML was slow, but then JSON was also slightly less slow. Because I mean, these are all kind of stuff that needs to be constructed and parsed, and it's got a bunch of anyway. They're very inefficient in terms of processing and size, right?
I mean, of course, the idea is pretty much the same, to have machine independence and programming language independence.
Mm-hmm.
Pretty much like the IDLs of the RPC area.
Sure, but it doesn't have
only on a different level.
Text-based, though, does it?
Well, yes. I mean, normally what you can do is actually, and most of the libraries actually do this already. If you have a JSON-based payload, they will normally compress this. But again, the idea is that you allow inspection of the payload. So binary, just because of security concerns, is pretty much out of the question, because you can decompress a compressed JSON payload, and then you can take a look at it being a firewall or intrusion detection system or what have you. So security is becoming more and more important, and so the technology does change. But the beauty is now that computers, and that's not just since Mr. Moore coined the term, that computing power is increasing more and more and more and more.
But I mean, okay, so inspection, but how does that doesn't really work for protobus, right? Because this is a binary.
This is the reason why protobuf has slightly fallen out of favor, because it's a binary format. Either the network can.
What are you talking about?
No, I mean, if you take a look at GitHub alone, the projects that use
GitHub, isn't that the Microsoft thing? Anyway,
yes. No, I mean, it's more or less. I mean, if you're talking about protobuf deployment, if you're not talking explicitly about network-based client-server architectures, protobufs normally use machine internally, or at least within a subnetwork where there is no firewall in between, no packet inspection or whatever, because either you explicitly whitelist set payloads, or chances are that at least the firewall say, sorry, it won't happen because I cannot kind of take a look at the payload. So this is the reason basically why, if you're talking about especially asynchronous distributed traffic that is crossing network boundaries, REST APIs, as in JSON-bound payloads, are the method of choice these days, especially if you're talking to, say, web server front ends. Never mind what comes behind them.
Yeah, but if you're running something at scale, like an Uber or a Netflix or your Metas of the world, you're not going to do everything internally with this JSON nonsense, right?
Yeah, this is the reason why they have their own content delivery networks, as in the CDNs, as in planet-wide. Because essentially what they do is they deploy a global CDN, and the CDN, in combination with some clever network techniques, I'm talking about VLANs and all the rest of it, construct a global overlay network across your ordinary TCP stacks. But this is transparent to the applications, because the applications simply pump byte streams through the network, and then the CDN takes care of the rest.
Yeah. Okay. So what about the more modern stuff.
That is modern. No.
I mean, okay. So protobuf is still a serialized protocol, even though binary. But there are more modern approaches, right, where you actually try and do zero copy rather than serialize and deserialize at the other end, like flat buffers.
It depends on the protocol, and it depends on the network in between. Come on, what are flat buffers?
Well, they are zero copy. So you kind of what you're doing is really, creating a format that's the same as in memory. So you don't have to do that serialization, deserialization step. So you're basically moving a in-memory object, which is The term zero copy is a little bit.
It does.
Anyway,
it does make sense because all of the architectures on this planet are AMD 64 anyway. So the trouble, of course, is that the smartphone manufacturers have to wake up to this fact. But because about 99.5% of the smartphones would use a different ISA with a different CPU architecture.
Yeah, I mean there are obviously different applications for all these things, but
so I mean if you're talking about high performance clusters, all residing in the network, of course. Yeah. But then you probably would use techniques such as NUMA, because if you're talking about a local network, the difference is just a network stack, no firewalls in between, because you are in your own enclave.
No, but you still have processing time to do the serialization and deserialization. If you don't have to do that, then so NUMA, you're just talking about pages, but that's not the same
exactly. Yes,
it's not the same as
you would simply page exactly. You would simply page memory across the network. If you're talking about a local performance cluster.
A flat buffer is more like a complete data structure, right? So it's not just a page.
No, agreed.
Okay. Yes. It depends what you're trying to do. Yeah, fair enough.
But I mean, if you're talking to the other side, to a server on the other side of the planet with about 20,475 firewalls in between, you want to make sure that your payload is something that these firewalls can take a look at. Otherwise, chances will be that your packet never makes it. Anything else before we close this off? Post-quantum IPC,
We also haven't discussed the open source angle of this stuff, right? Anyway.
All the stuff is in good help.
No. But I mean, what's his name? gRPC has obviously been, it's been adopted, whatever you want to call it, by the CNCF because of its
globally
usage. Yeah.
Exactly. So has protobuf.
No, I mean it's quite heavily used in Kubernetes, right? So that's why it's part of the CNCF. And we also have missed out the model contact protocol.
The model context protocol. What is the MCP?
Since the year is 2026, we have to talk about AI. Well, we don't have to. But,
So the idea behind the model context protocol is being able to speak to your LLM or other artificial intelligence stack of your choice.
It's more the other way around, where your LLM can talk to the rest of the world. But
same thing. It's essentially how.
No.
It's essentially an approach on how
giving your LLM the keys to.
It's about how to slot an artificial intelligence architecture, for want of a better expression, into your tech stack.
Something like that. It's really giving LLMs access to whatever service you want them to have, right?
Imagine you wake up one day, you get that mail. Please write a weather prediction server by close of business tonight. Please use 40,705 qubits and pick a quantum-based list dialect of your choice. Needless to say, you don't know what qubits are. You don't have the faintest idea, being a Rust developer.
This is really simple. You look at today's weather, and then You say it may or may not rain, and it'll be roughly the same temperature. Sun may shine. There you go. That's your weather prediction app.
let me continue with the example. So you fire up VS Code because they
don't need any qubits for that. Anyway,
of choice, and then you install a plugin that is able to talk what's what I'm looking for? That is able to talk quantum Lisp. And you instruct and you instruct the language server that was part of this plugin to come up with the code that would implement this by close of business. Now, what the language server does, because it doesn't have the faintest idea of how to construct this code base, it actually goes off to an LLM and asks, now look, I need the implementation in quantum Lisp.
No. That's just an API call. No. Yeah. The MCP is the other way around, where your LLM can say, talk to your weather service, give me your data, and I will do something with it.
I'm just sticking with the language server example, if you don't mind.
Oh, okay. All right, fair enough.
In that case, the language server would instruct the LLM to come up with not just the syntax coloring of said source code, but rather the source code itself.
Okay.
This is the overall idea. So essentially, model context protocol, and that was devised by Anthropic in about 2022 or 2023, when this whole LLM rage just took off. The idea is basically that an LLM or something similar can talk to your stack or the other way around. And that's all there's to it.
No. But interestingly, this was built on JSON RPC, this MCP protocol stuff. But they are looking to move it to gRPC as well.
So it's old wine in new hoses, exactly.
Yeah, I mean, all these protocols are the same. They're just kind of different implementations.
So kids, forget about the last hour.
Yeah.
Another hour wasted, but who's counting anyway? And with that, probably it's time to come to the boxes before we lose the rest of the audience. Exactly. So, Martin, what's your POX?
My POX is something called the Copenhagen test.
That tests if Copenhagen does exist?
No. It's actually a test that is used in the security services where you have to make the right decision in a certain situation. But that's not really that's the name of the series. But it's quite an interesting program series that has
it's like a TV series.
Good twists. Yes.
Okay. So you're watching TV again?
Yes.
You never really stopped? I see. Okay.
Occasionally, yes.
Anyway. Yes. Like every single day, but just for a couple of hours?
No, not every single day. No, for sure.
Okay. My POX is actually a community event taking place every year down in northern Italy, an autonomous province called Tyrol. Where they speak
Tyrol. That's in Austria.
Tyrol,
yes.
exactly.
Tyrol.
No, Martin, it's
Tyrol
in
is in Austria. Yeah.
No.
Yeah.
South Tyrol.
It's in both, obviously. Yeah.
Yes. So South Tyrol would actually belong to Italy because it's an autonomous province. And there's a city.
Yeah, okay.
Exactly. And there's a city called Bolzano where they run a community event that is older than FOSDEM.
Why is it there?
I don't know.
Oh,
it has always been there.
Something to find out in that case.
Exactly.
Something for another episode. Yeah, okay.
Exactly. So it's older than FOSDEM. It's almost as big as some of the bigger community events here in Germany. It's clocking in about 1,000 members of the audience going down there every single year. Substantial, exactly.
Very good.
And we may, or no, not we, but rather you may hear more about this in the coming episodes.
Yeah,
that's a cliffhanger. In layman's terms, exactly. No, Martin, this is not the point.
Probably nothing.
It's a community event, Martin. Very important.
Yes.
So people stay tuned.
The event needs sponsors, right? So do we. Anyway.
To be continued, as they say.
Yes.
Yes, exactly. This is called a blatant teaser, and I hope it does work. So stay tuned. And with that, see you next time around. This is the Linux In-Laws.
You come for the knowledge.
but stay for the madness.
Thank you for listening.
We hope you like this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.